Only till right here. Oh, I gotta draw. Right there. Okay, so it says values of the domain that need to be included or excluded to make the function reasonable. And then I have an example right there. For example, if the function h of n gives the number of person-hours it takes to assemble n engines in a factory, then the positive integers. What's an integer, Jason? What's an integer?
It's a whole number.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and -1, -2. But this says positive integer. So he said a whole number. Would that work?
Yeah.
Yes, it would. He didn't know,
Thank you
but
for saving me.
you're welcome. So then it says, then the positive integers would be an appropriate domain for the function. Why wouldn't negative values be appropriate? According to this example, why wouldn't negative make it appropriate?
Because you don't want a negative engine.
Okay, very good. We can't have negative hours. We can't have negative engines. Unless we have a time machine. Okay. All right. So let's move on. You didn't get the rest of it? Hold on. Let me. Okay, this says graph the function using the intercepts, then determine if there needs to be a restriction on the domain. So we need to remember how to graph doing intercepts. What do you know about the x-intercept?
It's whatever. W.
So the x-intercept is when what value is 0?
Why?
Okay, so I can put a 0 right here. Do you guys follow me? That means, according to my function, that all of f of w has to be what? So if I take this right here, and I solve 0 equals 2w to find out what w is, how do I solve that equation? Divide by 2. If I take 0 divided by 2, what do I get? Okay, our y-intercept is when what? X is 0. If we put 0 in for w, what do we get out? Okay, we got problems here. Because when I go to graph this, what's going to happen, guys?
It's just going to be a dot.
Okay, I don't have a function, do I? So, if you get to this point and you don't have a function, we're going to create a table. So we've already used 0. How about -1? And it's not really x and y. What is it?
W.
W and f of w. But could I put x and y here and you guys are still following me?
Yeah.
Okay, so if we choose -1 and we put that into our function without showing you the work, what do you get out? If I put -1 right here into the function, which means it also goes right here, right? We get -2, so I can put -2 in my table. We already have 0, 0, so we don't need that, do we? Let's try a positive number. If I put 1 in, what do I get?
2.
Okay, can we graph it now? Okay, so I come over here. I'll try to make it a little bigger. We go back 1, down 2, and we go over 1, up 2. What kind of equation do we get? Yes. Okay, so it says, we're going to read what it says now. It says the length f of w of a rectangle is twice the width. What values would be inappropriate for us to consider with this context? You have a rectangle, right? Can you have a rectangle that has a width of -2? No. So what would be appropriate for us to use here?
Positive integers.
Okay, and we're only going to talk about the domain because that's what it's asking you to do. So when I talk about a restriction on the domain, this goes back to when we talked about set notation, not interval notation. This is set notation. Okay, so set notation, I use this, right? Set notation, what am I going to say about all of my x values? And do I want to use x or do you want me to use w? Okay, I'm okay with that. What do we know about x? X such that x has to be what? Why bigger than 0, not equal to 0? Yeah, we can't have a width of 0. Sorry, that has a little a curly in there.
I thought it was cool with the curly, but I still can't draw those, so I just...
Okay, so should we actually use P and F of P in this?
No.
Okay, if I were to write an ordered pair, it would look like this. Nope, it won't.
It doesn't look like.
Yeah, it's nothing, so we
It's
get
like
to
a
do
white
nothing.
square.
I know. I told you, you have to get used to this. Okay, here, let's try that again. If I were going to write this in a notation for ordered pair, this says whatever I put in for P, what will you get out?
50 plus 2.
F of P.
This thing.
Or you could write 50 plus 2P. I like that. Okay, so if I want to identify my x-intercept, some of you guys, you weren't following me on the last one for the x-intercept, right? The x-intercept is when, which of these two values is 0? The P or the F of P? The F of P. So I'm going to take this equation, F of P, and instead of having F of P, what are we going to put there?
1.
So 0 equals 50 plus 2P. And how do we solve this?
Put 0 in for P.
No, don't put 0 in for P. We've replaced the F of P. So at this point, you're solving for P. So not plus 50.
Minus 50.
Oh. Okay.
So 0 minus 50 is
Negative
equals
2.
2P. How do you solve for P? Okay, so over here I get what?
Negative 25. P equals negative 25. Am I plug that into the thing?
Okay, so now we got to try to find the y-intercept, right? For the y-intercept, which of these ordered pair values is 0? The first one or the second one? The first one. We talked about this the other day, right? So what does that 0 represent in our function?
X. Just don't have no idea.
It's our x value. In this case, you would say f of 0 equals what?
Equals 50 plus 2.
50 plus 2 times 0.
See why you did that now.
I hope you guys see that. I'm seeing that. So what is f of 0?
50.
Yes, exactly.
Wait, so P is Y?
And that will give you your y-intercept.
Oh, because you times 2 by.
Yeah, 2 times 0, 0, so it's just 50. Hey, if it's not working doing the x and the y-intercept, can you do a table of values?
Okay.
Okay, you can always do a table of values.
I was like, where's the table of values at?
I didn't do it on here.
Okay, because you confused me.
Okay, when you go to graph this, you got to determine our scale.
Wait, is this what's on the extra worksheet you gave us for extra credit?
No. What's our scale that you guys are going to go by? 5s? I like fives.
I like fives.
If you want to go by tens, you can go by tens, but I like fives. So my first one is back 25, up 0. So I'm going by fives. 5, 10, 15, 20, 25. Okay, my y-intercept is over 0, up 50. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. So for those of you guys that went by, not by fives, it might be better, correct? If you went by tens, you'd have a smaller graph. So let's see if I can connect these. Oh, I'm close. I wonder if I can grab that and move it. And then you have to talk about your domain.
And then there's the lab.
Okay, what do you know about, I'm going to show you on the whiteboard. What happens for all of these values? Are they making any profit right here?
No.
Because we've got a flat fee of $50 and $2 per person to rent the pool for 2 hours. So after how many hours are they actually going to be making money? Yeah, what was your question?
What is the top dot?
This was my 050.
0.50?
Yeah.
Okay.
So what do you know about
Go
your,
back to standing by me, please. Thank you.
sorry, what do you know about your domain?
That it's
If I write it down here, I hope you guys can see it.
X.
it's X.
X.
So the little line thingy.
X such that,
Yeah, that thing.
can you guys see it under that little Doceri desktop trial? X is what?
Greater than negative 25?
Higher than greater than 0.
Greater than 0. Very good.
Why is it 0?
Because at 0, right here, this is where you finally get positive values.
That's 0? I thought that was 50.
Over 0, because domain refers to our x values, right? Not our y values, our x values.
Yeah?
Okay.
Oh, that's 0.
Yeah.
Okay, I get it.
Oh, geez, sorry. Erase that. What?
Stupid freaking X and Y thing.
Yeah, you're always going to look for them to find their intercepts. If you can't, by doing that, then you'll just do a table. Okay?
I hate X and Y. I hate where we have to.
All right, so this says to determine if this point, can I circle it? And you guys will know what I'm talking about? No, I can't.
Yeah.
Hold on. Can you see this point? What do you think it wants you to do at that point? Plug it in. So what does the first value represent? X, the second value is?
Y.
So if I put those in, it's going to look like this. 5 is what? Greater than negative 1/3, then what? Times 3, negative 3, thank you, and plus 2. And we're going to solve this. So we have a 5 over here. What's negative 1/3 times negative 3? 1 plus 2. And you're going to look at this. Is 5 greater than 3? So is this point a solution to the inequality? Yeah, why yes? Because it's true. I love that. So yes, because our inequality is true, then that is a solution. And next unit, we're going to talk a lot about what that graph looks like. So explain to me again how we got yes there. Who can do that? We plugged in the numbers, and what did we look at with those numbers? To see if it was true. Okay, so we go down to B. Do you guys want to try this without me, or do you want me to walk you through it?
Wait, so the solution to an inequality or?
Well, that was an inequality because it gave you an inequality. What do we have on B? And equals. So we have an equation. So how do I who can tell me how I substitute this in? Taylor, go.
The 7 is the Y.
So 3 to the minus 4. What is 3 to the 1? Minus 4 is?
Negative 1.
This is true? No. So is this point on that curve? Do you guys know that that's what that says? This point, that 1, 7, is not on that curve. Why am I saying a curve there? It's exponential. Can you guys tell me just by looking at that what it approaches? Yes, I love that, you guys. This right here tells you what it approaches, if you remember. Okay, that's all I have. Isn't that? Is that it?
Yeah, we're done.